Hey everyone, welcome back to the channel. Today, we're diving into one of the most mind-blowing questions in science. If the universe is full of stars, millions, even billions of them, then why is space so dark? Shouldn't the night sky be lit up everywhere we look? The answer seems simple at first, but it opens a gateway to some of the deepest ideas in astronomy, physics, and the nature of our universe. This question has a name: Olbers Paradox. And to answer it, we have to explore the age of the universe, the limits of the speed of light, the expansion of space, and how our eyes perceive light. It's not just about stargazing, it's about understanding why we see what we see, and what that tells us about the cosmos. So buckle up, because this isn't just a question, it's a journey through time, space, and the edge of human knowledge. Let's start with the basics. The universe is vast, so vast that even the numbers feel meaningless. We're talking about over 200 billion galaxies, each with hundreds of billions of stars. That's more stars than grains of sand on all the beaches on Earth. So, if there are stars in every direction, shouldn't the night sky be flooded with light? That's the logic behind Olbers' Paradox. In an infinite, static universe, every line of sight should eventually land on a star, and the night sky should be bright day and night. But clearly, it's not. When we look up, what we mostly see is darkness, sprinkled with the light of a few thousand visible stars. This paradox puzzled scientists and philosophers for centuries. Some early thinkers believed the darkness of the night sky proved the universe had boundaries. Others thought interstellar dust might be blocking the light. But as we developed better tools and deeper understanding, the real reasons began to emerge, and they're much more fascinating than you might think. One of the key factors is the finite speed of light. Light travels incredibly fast, about 299,792 kilometers per second, but it's not instantaneous. When we look at the night sky, we're not seeing the stars as they are now. We're seeing them as they were when their light began its journey toward us. The farther away a star is, the longer its light takes to reach us. And because the universe has a finite age, about 13.8 billion years, there's a limit to how far we can see. This is called the observable universe. Light from stars beyond this limit simply hasn't had enough time to reach us yet. So even though there may be countless stars beyond that cosmic horizon, their light hasn't arrived, and that contributes to the darkness. But that's not the whole story. The universe is not just finite in age. It's also expanding. And it's expanding fast. Galaxies are moving away from us, and the farther they are, the faster they move. This expansion stretches the light waves traveling through space, a process known as redshift. Light from distant galaxies gets stretched into longer, redder wavelengths. In extreme cases, the light is stretched so much it shifts out of the visible spectrum entirely and becomes infrared or even radio waves, completely invisible to the naked eye. So even if light from a faraway star does reach us, it may no longer be visible. The expansion of the universe, therefore, dims the distant cosmos even more. Now, let's talk about how our eyes work. Human vision is limited to a narrow band of the electromagnetic spectrum, what we call visible light. Our eyes can't detect infrared, ultraviolet, X-rays, or radio waves. So while the universe may be glowing in these other wavelengths, we simply can't see it without special instruments. That's why when we look up at the sky, we don't see the full glow of the cosmos. It's like trying to hear a symphony through a tiny hole in the wall. We only catch a sliver of the whole performance. In fact, when we use tools like the Hubble Space Telescope or the James Webb Space Telescope, which can observe in infrared and other wavelengths, we see a much more vibrant and active universe. These instruments reveal galaxies hidden behind dust clouds, stars being born, and ancient light from the edge of time itself. So in a sense, the universe is glowing. It's just that our eyes aren't equipped to see it all. Another important factor is the concept of entropy and the second law of thermodynamics. Over time, energy spreads out and systems tend to move toward equilibrium. The universe is heading toward a state known as heat death, where everything is evenly distributed and there's no more usable energy. The night sky's darkness is, in part, a result of this natural cooling and spreading of energy across an ever-growing cosmos. It's the ultimate quieting of the universe, a cosmic whisper that grows fainter with time. So, let's summarize. Why is space dark, even though it's full of stars? Because the universe has a finite age, and light from distant stars hasn't had enough time to reach us. Because space is expanding, stretching that light into invisible wavelengths.